Okay, so the first problem in our Math 2 review session, we have a circle D with radius 4 centimeters. We know that the segment AHT is tangent to circle D. We also know that FT is parallel to HC, and that the arc measure of FC is 60 degrees. No, you're not late. I'm just getting people started. So go ahead and get started on this problem, and then maybe in about 5 minutes, I'll call on someone to solve it for us. So, all right, let's resume recording. So we know that FT and HC are parallel. We also know that the arc measure of FC is 60 degrees, which means the inscribed angle FTC is 30 degrees. Because the lines FT and HC are parallel, that means angle TCH is also 30 degrees. Because AHT is tangent to circle D, it is perpendicular to the radius at TD. And we have set up a 30, 60, 90 triangle with the diameter at CT equal to 8. So which trig functions are we going to use to solve for TH and CH?
Could you do tan of 30 and sine of 30 degrees?
Yeah, so tan of 30 degrees equals opposite over adjacent. So opposite is HT and adjacent is CT. We know CT is 8. Therefore, HT is equal to 8 times tangent of 30 degrees. So if we do that in our calculator, let me make sure I'm in degrees. 8 tangent of 30. I got about 4.618. 4.62, and we're in centimeters. And then you said to use sine for CH?
Yeah.
Yeah, you can use sine or cosine because now you have the two legs. Oh, and you could also use Pythagorean theorem. So let's do sine of 30 equals opposite over hypotenuse, which equals 4.62 over HC. Therefore, HC is equal to what? Right? If you do the algebra. So let's see what that answer is. I got 9.24. What about y'all?
I got the same thing.
Awesome. Great. One problem solved. Are there any questions on this problem that we just did? No? All right. Make sure to ask questions, y'all, if you're confused. Okay, so we are to find the
can you scroll up a bit?
Yeah.
I just want.
Wait, how come you extended the line for like CH?
This is how it was given.
Oh, okay.
Yeah. So HT is a tangent line, and so CH should go outside of the circle.
I'm good, by the way.
Okay. All right, so this problem, we're supposed to find the area of sector AFD. So let's outline that. And here's what we are given. So we have a circle F. So this means circle with center at F, radius of 8. A measure of angle AFB is 80 degrees. BD and AC are diameters. And that's it. So how should we solve?
AFD would be 100 degrees because it's like a line. So you do that. And then the whole circle is like pi r squared. So it'd be 64 pi. And then you can set up a proportion to like 100 over 360 and then x over 64 pi.
Cool, awesome. Does everyone understand why that proportion is set up and what Lisa did?
But can you explain that a bit slowly?
Yeah, so we know that BD is a diameter, and we know that angle BFA is 80 degrees. So because it's a diameter, a straight line, right, the full degree measure has to be 180 degrees, which means the angle DFA is 100 degrees. So we're trying to find the area of this sector, and we can set up a proportion to say that the degree measure in that sector over the full degree measure of a circle should equal the area of that sector over the full area of a full circle. Does that make sense?
Wait, can you repeat that ratio again?
So the degree measure of the sector over the degree measure of a full circle should equal the area of the sector over the area of the full circle.
Oh, okay.
Make sense?
Yeah.
And so then we can solve this proportionality statement for x. So x is equal to 100 over 360 times 64 pi. And you can leave this answer in terms of pi if you want. Let's see what we get. 100 over 360 times 64. Wow. Yeah, let's see. Math fraction. So I got, in terms of pi, 160 over 9 pi. And in terms of a decimal, that's 55.85. How did I get 64 pi? Sure. So the area of a full circle is pi r squared. R squared. And the radius is 8. So we do pi times 8 squared. Questions?
Could you put it like on the test in like decimal form in pi? So like okay, thank you.
It's like 17.7777 pi.
Yeah.
So yeah, so you can, I would prefer it in a fraction, but if you do it that way, I'll be able to figure it out. Just know for future reference that if you have a number times pi, they usually want a whole number or a fraction and not a decimal. So if you can turn that 17.77 into a fraction by using the math fraction function on your calculator, that would be best. Yeah, that would be best.
How do you do that on the calculator?
Sure. So 3 keys down from the second button, there's a button that says math.
Yeah.
So you press that button. And then the first one says like arrow fraction. So that will turn your answer into a fraction.
Oh, okay.
So if you just press that one button. So for example, if I did, what was it? 100, oops, 100 over 360 times 64, that gives me a decimal approximation of 17.77777 blah, 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 8. Then I press math fraction and type that in. So it'll do answer converted to fraction.
Mhm.
Press enter, and then I get 160 over 9.
Oh, okay. Thank you.
All right, other questions before I move on from this problem? I will be uploading this sheet as well as the video on Compass, just so y'all know. Okay. So next problem, we are given that, well, this should say circumference. Circumference of circle H is 10 pi. Which is the measure of angle AHC is 30 degrees. Find the arc length AC. What do I do?
Don't you like take 30 degrees and divide it by 360 and then multiply it by the circumference, which is 10 pi?
And that also comes from a proportionality statement. So the degree measure of the sector to the degree measure of the full circle should equal the arc length, which is what we're solving for, of the sector over the full arc length of the circle, i.e. the circumference. And so if we rearrange this and solve for x, the arc length, 30 over 360 times 10 pi should equal that arc length. So go ahead and try and practice this one to put it in a fraction. So a fraction times pi. Let's see if that'll work out. Yeah, it should. So let me know y'all's answer in terms of a fraction times pi. Yes, yes. Okay, so I see two answers in the chat that the arc length x is 5 pi over 6, or you can write it as 5/6 times pi. Good, awesome. Any questions about this problem? This one was kind of like an easier version of the last one with one step. All right, so this last problem is kind of a doozy, and I did it on purpose because there's a harder problem on the test that is similar, I guess. So let's see. We are given that AB is tangent to circle D. CF is also tangent to circle D. The measure of arc AE is 70 degrees. The measure of arc CH is 20 degrees. The radius is 2 meters and AC is the diameter, and we are asked to find EB. Think it over for a hot second, and then let me know if you have any ideas.
Do tangents form a right angle?
Yes, tangent lines to a circle form a right angle with the radius. Oops, sorry. So angle BAC is a right angle, and angle ACF is also a right angle. What else?
Angle measure ACE is 35 degrees.
Mm-hmm.
And
How did you get that?
because an inscribed angle is half of the arc measure and the
Mhm.
central angle.
Mm-hmm. And keep going. Sorry, I cut you off.
And, and angle CAH is 10 degrees
Mhm.
because of the same idea.
Yeah. What else? We almost have enough information to solve this problem that I've written down. I think there's one more piece of information, and I think you'll all be able to solve.
Angle ABC is 55 degrees. If I did that right.
Mhm. What else?
Wait, how is it 55 degrees?
35 plus 90 is it's 125. And then 125 plus 155 is 180.
Oh, okay.
Diameter is 4 meters.
That's what I'm looking for. The diameter is 4 meters. Let me write that down. AC is 4 meters. Yeah. Y'all have any idea yet? What about, can I solve for the length of CB?
Yeah.
Using trig functions. So like cosine of 35 degrees is 4 over CB,
Mm-hmm.
and then CB is equal to 4 divided by cosine of 35 degrees.
Yep. Good. So let's calculate that real fast. That's half of our answer. So we solve for BC. And in order to solve for BE, what else do we need to solve for?
CE.
Correct. Yeah, so for this one, I got 4.88. And so, yeah, so we also need to solve for CE. Can we do that?
How would we do that?
Dun, dun, dun. You can do that. And you have to draw a construction. You have to draw an extra line.
You can make a line from A to E.
Mm-hmm. And then what happens?
You have
It's a 90-degree
So you write
triangle because
triangle.
it's inscribed from the diameter.
Dun, dun, dun. Yeah. And so how do we solve for CE now?
Wait, why is it a right triangle?
Because AC is the diameter.
So would EAC be 55 degrees?
Mm-hmm.
Wait, so then you can literally just use trig to find BE. Here,
Yeah.
Huh, funky.
Yeah, So let's find CE real fast. How do I find E? CE?
Cosine of 35 degrees.
Equals,
Four
you're right on
over
time.
CE.
Almost. So this is the right
CE
angle
over
now.
4.
Yeah.
Oh,
CE over 4. So now we have that CE is equal to 4 cosine of 35, which is 3.27.
Mm-hmm.
So now we have CE and CB, and we want EB. So what do?
CB minus CE.
Yeah, CB minus CE gives us EB. So 4.88 minus 3.27 equals
I got 1.61.
Yeah.
61. Awesome. And that would be what unit?
Meters.
Meters.
Oh, this is really cool.
Right? That was a fun problem, right? I'm feeling like I might put one like that on there for extra credit, but there's one very similar to this one and the first one we did that you will be helped out by doing this kind of stuff. All right, I'm gonna pause the recording for 1 hot second and we can talk about what we'll do from here. Zoom recording. Okay, so we have a hexagon. I'll say that the radius is 8 meters. Inscribed regular hexagon. And I want us to solve for the area between polygon and the circle, just like we did yesterday. And then I'll do one that, yeah, Stephanie?
I was just gonna answer, but you're still talking, so.
What?
But I was gonna try and answer some of it.
Oh, okay. Okay. Give me 1 second. We'll do a regular polygon and then we'll do one like the triangles and the boxes that were there yesterday. So Stephanie, you wanna start us off?
Yeah. So you have to make a section of into a triangle. And then you'd have to split in half, put out to 2. And so then you'd have to you'd have to figure out the angle on the top. And so it would be 30 degrees because the full angle at the top is 60 because of a hexagon divided by 360, 60 degrees. And then you'd have to figure out the altitude length and the half of the triangle length to find the area of the triangle.
Mhm.
And to do that, you need to use trigonometry. To find x, you need to do sine of sine of 30 equals x over 8, which is also 8 sine of 30 equals x. And that is it's 4 exactly.
Mhm. So we have the base.
Yeah, and then we have to find h, and we can do that by using trigonometry again. We could do cosine of 30 degrees equals h over 8, which is also 8 cosine of 30 degrees, and that's like 6.93, something like that. And then you'd have to multiply h and x, and then you multiply x times h and also times 6, right? And then that would be the area of the polygon. And I got like 166.28, and then you'd have to, and then the area of the circle is 64 pi, and so you do 64 pi pi minus the answer, which would be about 34.79 meters squared.
Yeah. That was a great explanation. Does anyone have any questions for Stephanie?
Wait, wouldn't you multiply xh by like 6 because not 6, 12, because multiplying by 6 only gets half, right?
But x times h, because the area of a triangle is base times height over divided by 2. So x times h, even though it looks like it's only the area of like the smaller triangle, it's actually the area of the whole triangle. You're just not dividing it by 2. Yeah.
I forgot about the divided by 2. My bad. Thank you.
Cool. Basil?
Isn't there like a formula for this? Finding the area of, well, not the shaded part, like finding the area of a polygon inscribed in a circle.
I think so. It's either the area or the perimeter, one of those two we went over. The main thing that you need to know is that in order to find one of these small angles, it's 360 over 2n. But I'm sure there was an equation. But the thing about that is like you're not like supposed to memorize those. You should be able to derive them like we did here, if that makes sense. So if you do memorize them, you can use them, but make sure that they are derived correctly.
Okay. Thank you.
Here's our final answer. Okay, so we did one with a regular polygon. We should do one with a like some of the ones we did yesterday with triangles and boxes. Let's see if I can draw it. Stop sharing for a second. So besides the inscribed polygon problems, are there any other types of problems y'all would like to go over?
Could we go over one that like it's got poly or shapes in it, like some of the questions, like the questions we did in the practice for the test, like where it had like a rectangle and you had to solve like the outside of the stuff in between or something like that. I don't know.
Yeah, that's what I'm trying to come up with right now. We'll see. let's see. Yeah. All right. So let me write through. Why can't I spell? Okay. Am I recording? All right. So we have 3 equilateral triangles inscribed with vertices at the center. Solve for the shaded area. Oh, and the radius is 10 inches. Looks like a hazard sign. Yeah. Could I try solving it again? Maybe. Yes. Yeah, you can try solving it again.
Well, so
Excuse me.
is there like a way to find the angles in the middle?
I don't know. You tell me.
Okay.
Read the prompt again. It might help you.
Oh, so you could you could take a triangle and draw an altitude through the middle of it, and then basically solve it kind of like how you did it in the earlier question. Half of the triangle would, yeah. So wait, but
Anyone have any ideas how to find the angles from the center?
Is it 60 and then you have to divide by 2 to get 30?
how
Why
do we
is it-
know it?
Yeah,
Oh.
why is it 60 degrees? Faisal.
Because it's an equilateral triangle and all angles are in the equilateral triangle are congruent.
Correct. Awesome. Yeah, so 1/2 of that will be 30 degrees, right? Now what do we do?
Well, we know the hypotenuse of that right triangle is 10 inches because that's the radius.
Mhm.
And then you could use like sine of 30 to find the base part, and you could use cosine of 30 to find the other side, the altitude.
Mhm. Yeah. What are those equations of sine and cosine?
Sine is x over 10, and then cosine is h over 10. And for the sine 30, you would get 10 sine 30 equals x, which is calculator 10 sine of 30, exactly 5, and then cosine of 30, that's just 10 cosine of 30, and that's 8.66.
Cool. Now what?
You could do the base times height divided by 2, so just multiply x by h, which is just 5 times 8.66, and that would just give you the area of that full triangle. So you don't need to divide it by 2. Then
Yeah.
you get the area of the full triangle.
Mhm. So the reason I wrote it why I did, dividing it by 2 and then multiplying it by 2, is because that's what's actually happening in our head. We divide it by 2 for the half of this, and then we multiply it by 2 to get the full one. So I'm just writing it out like that. And so we should get 43.3 inches squared for that one triangle. And then what?
And when you multiply that by 3 to get the area of all the triangles, and then you would subtract the area of the circle and the areas of all the triangles to get the space in between.
What's the area of the circle?
It's 100 pi.
So the area of the shaded region is what?
It's is it like 184.26 inches square?
Yes. But what operation did you do? I want to write it down.
Subtraction 100 pi minus 129.9.
Awesome. Questions? Someone raise their hand, or did I miss it?
How do we know that like those 3 triangles are congruent? Because like if we multiply by like one area by like one of those triangles areas by 3, then that means we're assuming that those 3 triangles are congruent, right?
Mhm. Why do we know they're congruent?
The same radius.
Mhm. Right, and I told you that they're equilateral, which means those are also equal.
Oh, okay. I see.
Any other questions? But I mean, that's a good point. If I had one triangle with 60 degrees and one triangle with like 70 degrees, you couldn't do that multiplied by 3 thing. Yeah, you'll have to do them separately. But since they're all equilateral and inscribed in a circle with vertices at the center, they're all congruent. Okay, other questions? I want to do a radian problem because I feel like we haven't done any of that. Let's see. 2 radians is equal to how many degrees?
360.
No.
Oh, wait. Isn't equal to
2
Wait.
radians, not 2 pi. 2
Oh.
radians.
it's equal to 360 over pi.
Who can help? What's the conversion rate?
360 over 2 pi is equal to x over 2 radians, or x radians over 2 radians.
Is equal to, I see.
Oh, well,
360 over
x degrees over 2 radians.
Yeah, x degrees over 2 radians. Now what? Now what? How do I solve for x algebraically?
360 over 2 pi times 2 radians.
So then our 2's will cancel out and we're left with 360 over pi equals x degrees. If we do that in our calculator, yeah, okay. X is equal to what?
I got 114.6.
Yeah. Do you remember when we solved for 1 radian? 1 radian and it was 57 something degrees
Yeah.
in class? Yeah. So 2 radian should be double that. That's how I was like checking my answers. I don't remember. So there's a difference, right? You can write radians in terms of pi or in terms of a decimal or a number, but the conversion rate is the same, right? It's always going to be either 360 over 2 pi or 180 over pi is the other way. Yeah. Why is it write so slow? Do y'all hear that? I think I'm going crazy. Okay, I have a question from the chat that says they need help finding the center of the circle using right angles. I know the steps, but I don't exactly know how to use a protractor. So let's just do one of those problems real quick. So there are 2 to 3 ways to find the center of the circle, and I will list them here. So you can find the perpendicular bisector of 2 chords. We can draw 2 diameters from right inscribed angles. And there's one we didn't talk about in class, unless you were in 7th hour because Aya brought it up, where you can draw tangent lines to the circle and lines perpendicular to them are the radii. Yeah, there's 3 separate ways. If I were you and I, let's see, so let's break it down. For the 2 chords, you will need a ruler and a protractor. Or if you know how to draw a perpendicular line with your compass, you can use your compass. For 2, you only need either a protractor or something with a right angle, like a book. If you don't have a protractor, you can put the edge of your book on the circumference of the circle and draw that right angle. For the tangent lines, you would need a same thing, protractor or book. So if I were to choose one of these 3 methods, I would choose 2 or 3 because it involves less materials that you need. But let's demonstrate all 3. So I have a ruler here. Can you all see my ruler?
Yeah.
Okay, great. So I'm gonna put this tick mark here and let's see, I want to make it match up with another tick mark so I know exactly how long it is. 1, 2, 3, 4, 5, 6, 7. Go for an even number. So 1, 2, 3, 4, 5. Dang it, an odd number again. So right in the middle of that, right, would be 2.5. And this angle is at 49 degrees. So I want to go perpendicular to that. Oh no. Literally there. Okay. No. There. 41. Dang it. All right. And then I'll draw a line like that. So this is an example of number 1. I have these two congruent. So this yellow line's at the midpoint, and I made sure that it was perpendicular to that chord. I'm going to draw another chord. Hopefully I can do it right this time. Let's do 45 degrees. So I'll draw this line 1, 2, 3, 4. So the midpoint is going to be at 2. And then I'll turn it to 45 degrees. And again, these are congruent, and this is a right angle. So this should be the center of my circle. So that's method 1, right? Let's do method 2 down here. So what I'm talking about when I'm saying like put a piece of paper down for your right angle, I have Post-its, right? So this, all pieces of paper have perfectly right angle. Otherwise we would have parallelogram notes, right? So you're gonna put this corner on the edge of the circle and trace it. Do I need to find the protractor for this test, or is this the only angle we need a right angle? You will not need a protractor for the test at all. The only angle you should be finding is a right angle, which is why I'm giving you the paper option. So put the paper down where the edge is on the circumference and just trace it. That's what I'm gonna do right now. Okay, where I draw the lines connecting those two should be the diameter, right? Then I'll take my piece of paper and draw another right angle somewhere else. Up a little bit. This is probably gonna be easier on actual paper. Well, that should be another diameter. And where they intersect should be the center of the circle. For this, I kind of made my circle look like an egg, so, or an ellipse, so it kind of looks like it's off center. But if you show work like this, then I'll understand what you're doing. For these problems, you need to show your geometric symbols, like the congruency symbols and the perpendicular symbols, so I understand what's going on. The last and final one I want to go over is the tangent line to a circle one. And again, I drew an ellipse. I really need a compass. So I'm going to draw a tangent line. Let's just do one right there. And if I draw a line perpendicular to where the tangent line touches the circle, and there should only be one point it touches, this line should match up with the radii, or the radius. So let's go ahead and draw another tangent line on the other side. That's kind of off tangent. Let's do that. And then I'll draw another perpendicular line where it touches a circle. And it should be the center. So this is option 3. Option 2. And option 1. Yeah? Okay, we have 4 minutes left. Are there any other questions you'd like me to go over? Any other types of questions you'd like me to go over? All this will be posted, yeah? How do you feel about the test on Tuesday? Looking at the makeup of this room, I think you will all do very well, but better, good. Scared but prepared. Yes, better, still nervous. Okay, the reason I said yes to that is because when I was a freshman, story time. When I was a freshman, I accidentally got pulled on the state math team because I accidentally got a good score, like I guess, but still got a good score. And so I went to Dr. Boca back when she was my teacher, and I was like, Miss Boca, I literally don't want to do this. she was like, Kayla, don't be scared, be prepared. So I started studying. So you all took a great step by coming here first thing in the morning, staying for an hour, asking good questions, making me take good notes. Hopefully you took notes of your own. Yeah, I think everyone will do fine. It's really, really not that hard. Let me stop.